Another problem related to coal is the problem of ash disposal. When coal is burned, it produces ash. In the United States, this amounts to approximately 140 million tons of waste. Coal ash contains a number of highly toxic chemicals, including lead, mercury, arsenic, selenium, and chromium. Most of the material is stored in aging ponds that are largely unregulated by the government. In 2013, a retired Duke Energy coal plant in Eden, North Carolina, leaked 82,000 tons of toxic coal ash into the nearby Dan River. The contaminated fluid traveled through a broken pipe underneath an unlined storage pit, sending 27 million gallons of water from a 27-acre storage pond into the river. Petroleum is formed in a similar way to coal. Organic material, buried in sediment and subjected to high pressure and temperature. An oil pool is usually composed of individual droplets or a thin film permeating spaces in porous sandstone, like water in a sponge. We recover about 30 to 40% of oil in a formation before it becomes uneconomical to continue. In the 1940s, Dr. M. King Hubert, a Shell oil geophysicist, predicted that oil production in the United States would peak in the 1970s based on estimates of U.S. reserves at the time. Hubert's predicted peak was correct, and subsequent calculations have estimated a similar peak in global oil production in about 2005 to 2010. Global production has not yet slowed significantly, but many oil experts expect that we will pass this peak in the next few years. About half of the world's original 4 trillion barrels, 600 billion metric tons, of liquid oil are thought to be ultimately recoverable. The rest is too diffuse, too tightly bound in rock formations, or too deep to be extracted. Of the 2 trillion recoverable barrels, roughly 1.26 trillion barrels in a proven reserve, commercially extractable using currently available technology. We have already used more than 0.5 trillion barrels, almost half of proven reserves, and the remainder is expected to last 41 years at current consumption rates of 30.7 billion barrels per year. Middle Eastern countries have more than half of the proven world supplies. Concern about environmental damage from drilling and oil spills like that of the Exxon Valdez in Alaska's Prince William Sound and the Gulf oil spill of 2010 make many observers worry about exploitation in such sensitive areas. Proven oil reserves. 12 countries, 7 of them in the Middle East, account for 89% of all known economically recoverable oil. Numbers add to more than 100% due to rounding. This chart from the United States Department of Energy provides an outlook for total U.S. oil production. Notwithstanding the idea that we may have reached peak oil, in recent years we continue to discover and utilize new oil sources. Since the 1970s, U.S. consumers have feared that there won't be enough energy to meet consumer demand. That has changed. We now know that we can recover significant amounts of oil to meet the needs of current and future generations. The U.S. now ranks as the world's top natural gas producer and the second largest oil producer, and may soon pass Saudi Arabia as the top producer. The U.S. Energy Information Administration estimates that U.S. total crude oil production averaged 8.9 million barrels a day in September 2014, driven largely by growth in tight oil production. To put that in perspective, U.S. total crude oil production averaged 7.5 million barrels per day in 2013 and 6.55 million barrels per day in 2012. Recent increases in U.S. oil production due to tight oil are the largest since Colonel Edward Drake drilled the first oil well in Pennsylvania in 1859. We've known for years that shale rock contains oil and natural gas that was too tight or impermeable to allow commercial production. Ongoing research and development optimized 2 key innovations. The first was hydraulic fracturing, also known as fracking, injecting water under high pressure to create narrow microfissures in the rock. Since the late 1940s, it has been used in more than 1 million wells. Separate research during the 1980s made it possible to drill wells that curve out laterally, thus gaining exposure to more potentially productive rock than was possible with conventional vertical wells. Hydraulic fracturing and horizontal wells were first combined in shale wells in the late 1990s, enabling commercial production of unconventional reservoirs. Most of us hadn't thought much about the dangers of deep ocean oil wells in remote places until the 2010 explosion and sinking of the Deepwater horizon in the Gulf of Mexico. At least 5 million barrels of oil were spilled during the 4 months it took to plug the leak. The well was being drilled in about 1 mile deep water, but that isn't very deep by current standards. For the Gulf of Mexico, the current record is held by the Perdido spar rig, which is drilling in more than 3,000 meters of water, and then to a depth of more than 6 kilometers below the seafloor. Brazil is drilling at a similar depth, about 186 miles offshore. This ultra-deep deposit, which Brazil estimates could hold 50 to 100 billion barrels, could make that country 5th or 6th in the world in oil resources. By some estimates, Venezuela could have more than 300 billion barrels of oil, more than even Saudi Arabia, accessible with current technology, but much of Canada's and Venezuela's new oil resources are from tar sands. Canadian deposits in northern Alberta are estimated to be equivalent to 1.7 trillion barrels of oil, and Venezuela has nearly as much. Together, these deposits are 3 times as large as all conventional liquid oil reserves. Tar sands are composed of sand and shale particles coated with bitumen, a viscous mixture of long-chain hydrocarbons. Shallow tar sands are excavated and mixed with hot water and steam to extract the bitumen. For deeper deposits, superheated steam can be injected to melt the bitumen, which is then pumped to the surface like liquid crude. Once the oil has been retrieved, it still must be cleaned and refined to be useful. The United States also has large supplies of unconventional oil. Oil shales are fine-grained sedimentary rock rich in solid organic material called kerogen. Like tar sands, the kerogen can be heated, liquefied, and pumped out like liquid crude oil. Oil shale beds up to 600 meters thick underlie much of Colorado, Utah, and Wyoming. If these deposits could be extracted at a reasonable price and with acceptable environmental impacts, they might yield the equivalent of several trillion barrels of oil. Mining and extraction of oil shale and tar sands uses vast amounts of water, a scarce resource in the arid western United States, releases much more carbon dioxide than burning an equivalent amount of coal, and creates enormous quantities of waste and wastewater, contaminates rivers and streams, and destroys the boreal forest. However, with rapidly rising crude oil prices in recent years, interest in this resource has rekindled. This is a photo of a Canadian tar sands extraction site. This activity takes place on a huge scale that can be seen from space. Copy and view the link for more information on the environmental issues related to extraction of tar sands. More than half of all the world's proven natural gas reserves are in the Middle East and the former Soviet Union. Both Eastern and Western Europe are highly dependent on imported gas. The total ultimately recoverable natural gas resources are thought to be 10,000 trillion cubic feet, corresponding to about 80% as much energy as the estimated recoverable reserves of crude oil. The proven world reserves of natural gas are 6,200 trillion cubic feet. Because gas consumption rates are only about half of those for oil, current gas proven reserves represent roughly a 60-year supply at present usage rates. Given the awareness among consumers of the impact of greenhouse gases, natural gas companies are emphasizing the advantages of this cleaner burning fuel. This table shows the amount of carbon dioxide produced per kilowatt hour of energy used. As you can see from these data, combustion of natural gas produces about 37% less carbon dioxide than combustion of coal. This graphic presents the proven natural gas reserves by region in 2011. Note that while the Middle East has extensive natural gas resources, their use is limited by problems related to the transportation of the gas to market. To ship natural gas by ship requires it to be cooled and condensed into a liquefied natural gas, or LNG. However, the amount of energy stored in a tanker filled with LNG is equivalent to a medium-sized nuclear bomb, so most major coastal cities do not allow LNG tankers to enter. Specialized ports were constructed for the import of LNG to the United States. Recently, because of the boom in production of natural gas from shale deposits, these LNG ports have been converted to export LNG. Here we see natural gas wells dotting the landscape of the Upper Green River Basin. Drilling for natural gas in tight formations has resulted in an economic boom in many rural cities and towns across the United States. The United States has 3% of world reserves, or about a 10-year supply, but it is estimated that there is twice as much that could ultimately be tapped. These are locations of major natural gas resources in the United States. The Marcellus and Devonian shales, which underlie much of the Appalachian mountain chain, contain a supergiant gas field. Current estimates of the volume of gas in the Marcellus shale range from 168 to 516 trillion cubic feet. Of this total, about 10% is considered recoverable given the current economic climate and available technology. Rising natural gas prices during the turn of the current century, coupled with technological advances, spurred interest in the Marcellus shale in northeastern Pennsylvania. Although the thickness of the Marcellus shale is greater in eastern Pennsylvania, the depth to the shale is also greater. Most of the exploratory and development gas wells in eastern Pennsylvania are drilled to depths ranging from 5,000 to 8,000 feet. Shale deposits are generally tight formations through which gas doesn't flow easily. To boost well output, mining companies rely on hydraulic fracturing, or fracking. Wells are drilled vertically to depth and then turned to be drilled horizontally. Once the well is constructed, explosive charges are set to create perforations, a process called perking. Wells are drilled vertically and then horizontally. Once the well is constructed, explosive charges are set to create perforations, a process called perfing. A mixture of sand, water, and various chemicals is pumped into the well and into the ground and rock formations through the perforations at extremely high pressure. The pressurized fluid cracks sediments and releases the gas. Fracturing rock formations often disrupts aquifers, however, and contaminates water wells. Drilling companies generally refuse to reveal the chemical composition of the fluids used in fracking. They claim it's a proprietary secret, but it's well known that a number of petroleum distillates, such as diesel fuel, benzene, toluene, xylene, polycyclic aromatic hydrocarbons, and glycol ethers, as well as hydrochloric acid or sodium hydroxide, might be used. Many of these chemicals are known to be toxic to humans and wildlife. The U.S. EPA recently forced mining companies to reveal the contents, but not specific fractional composition, of their fracking fluids used on public lands. These are various videos that can provide some pros and cons about fracking. Fracking has created a natural gas revolution and has allowed the United States to become the world's top natural gas producer. However, there is an environmental and social cost. Fracking is associated with air pollution, water pollution, earthquakes, release of greenhouse gases, contamination of drinking water, damage to livestock and crops, and accidents relating to transportation of toxic fracking fluids. New York State has banned fracking. In this lecture, we have learned about energy and how we measure it. We have also learned about fossil fuels and the environmental impact of their use. Fossil fuels remain our dominant energy source, but coal use is declining rapidly owing to problems with the extraction, use, and disposal of ash residues. Oil is an important resource, but easily available oil is not sufficient to provide our needs, and thus exploration and development continues, but in environmentally sensitive areas and by development of shale oil deposits and tar sands at greater cost. A new natural gas renaissance is underway, but with significant effects on residents and the environment near fracking wells. Again, fracking of tight formations provides access to previously unavailable gas and petroleum resources.